All right, ladies and gentlemen, we have made it to Unit 7, which is called Quadratic Equations. And this is a really super important unit, brand new. But you bring to this unit some prior knowledge on the quadratic trinomial. And we factored quadratic trinomials in the last unit. And to refresh your memory, quadratic trinomials were of the form ax squared plus bx plus c. Okay, and we factored these by unfoiling. Quadratic trinomials were the result of FOIL. All right, and what we're talking about today and starting to introduce is the concept of the quadratic equation. So the key word is quadratic, and let's talk about what a quadratic equation is. You're going to see it looks very familiar. A standard form of a quadratic equation is y equals ax squared plus bx plus c. Looks just like the quadratic trinomial because it is, okay? Now the difference in the quadratic equation is that it is y equals ax squared plus bx plus c. Now we have dealt with equations before with y equals. We used to call these y equals mx plus b's. Remember these? These were called linear equations. And the reason why these were called linear equations is because when you graphed them, they made a straight line. Okay? Quadratic equations, which are y equals ax squared plus bx plus c, when you graph this quadratic equation, it creates a U-shaped curve instead of a straight line. It creates a U-shaped curve called a parabola. Parabola. Okay? So, linear equations, y equals mx plus b, those made lines. Quadratic equations, y equals ax squared plus bx plus c, those create parabolas, which are U-shaped curves. Now take it to Desmos real quick. You can pause the video and take it to Desmos to draw a quick sketch of y equals x squared plus 2x minus 5, and then draw a quick sketch of y equals negative x squared plus 3x plus 7. So go ahead and pause the video and take it to Desmos to graph these two quadratic equations. Do that now. So hopefully you paused the video and took it to Desmos to graph each of these so that you can kind of get the idea of what it feels like on a graphing calculator, what the graphs look like, etc. And you should have noticed that this particular quadratic graphs upwards and this particular quadratic graph downwards. Now I'm not really putting them in the right spots, but hopefully you sketched a rough sketch of them. So your A term in the first parabola, in the first equation, your A term was positive, because in this case your A was 1 in the blue one. And if the A is positive, then the parabola opens upward like a smile. Okay? If A is negative, and here our A is negative 1, so if A is negative, then our parabola is going to open downward like a sad face. So there is our sad face. Okay? So again, we have the quadratic equation, y equals ax squared plus bx plus c. When you graph a quadratic equation, it creates a U-shaped curve. That's called a parabola. Whether the parabola opens upward or downward is dependent on the sign of A. If A is positive, our parabola opens upward like a smile. If A is negative, our parabola opens downward like a frown. All right, so here I have graphed on Desmos y equals x squared plus 2x minus 5. The A is positive, so my parabola opens upward like a smiley face. And there's a few other things I want to point out to you. One thing I want you to point out is at this point, and let's put a little like imaginary line here. At this point, what we have is basically what's called symmetry. So the left side of the parabola is exactly the same as the right side of the parabola. This is almost like that dipping point, right? That kind of cuts the parabola in half. So if I were to fold along this black line and fold the paper vertically, right, the green and the blue would touch each other. So that means that the parabola is symmetric about that line, symmetry, okay? So the left side is exactly the same as the right side when you have symmetry, you fold it along that dotted line. Okay, so that dotted line, that is called the axis of symmetry. Okay, the axis of symmetry, and that's the next word in your notes, axis of symmetry. So the axis of symmetry is like this imaginary vertical line. So it's an imaginary vertical line that goes through kind of like the middle of the parabola. It goes through, that's called the vertex. Okay, it goes through the vertex. And it kind of shows you where that line of symmetry is in the parabola. It shows you kind of how to cut the parabola into two equal parts. And that's your axis of symmetry. And again, I said, this right here, that's the vertex. So the vertex is either the lowest point, or if the parabola looks this way, the vertex is either the lowest point or the highest point in a, oh man, I cannot spell, in a parabola. So the vertex is the lowest point, or if the parabola is the other direction, the highest point of the parabola. And the axis of symmetry, again, is that imaginary vertical line that goes through the parabola, kind of showing you the two equal parts. So to kind of summarize here, the axis of symmetry is that invisible vertical line that divides the parabola into two equal parts. It's the fold line where you can fold the parabola and both parts will touch. And the vertex, that's that lowest point or highest point. It's also known as the turning point of the parabola. It's when the parabola goes from coming down, boom, to going right back up. Or if you're going in the sad face direction, the parabola goes from up to down. And we do read graphs like we did with lines. We read graphs from left to right, okay? So if you start at the left part of this parabola, the parabola is decreasing to the vertex and then turns up and increases. If you're looking at a negative parabola, it starts increasing, hits the vertex, and then starts decreasing. So the vertex is that turning point, that high or low point. So with that being said, when the vertex is the lowest point, the vertex is called a minimum, and it's called the minimum of the parabola. And when a vertex is the highest point, it is called the maximum, okay? And we're gonna spend a lot of time talking about all that. But how do you get the axis of symmetry or the vertex from a parabola, okay? And that's what I'd like to talk about and kind of finish off this video with. So remember that a quadratic equation is y equals ax squared plus bx plus c. The vertex is a point, and the axis of symmetry is a vertical line, okay? So to get the vertex, the x value of the vertex is going to be found by doing negative b over 2a. So negative b, there's a. Negative b over 2a, that gives you the x value of the vertex. And if you want to find the y value of the vertex of that point, this is doing it without a calculator, because obviously if you have Desmos, you just graph it and you can touch the vertex and it'll give you the point. If you want the y value of the vertex, that number that you got for x, okay, the number that you got for x over here, just plug it right in, because y is equal to ax squared plus bx plus c. And I'll show you what that is in just a second with this first example. So let's do that, and then we'll talk about the formula for the axis of symmetry. So here we've got a is 1, b is 8, and c is 15. So for the vertex, which is an ordered pair, now again, you're doing this without a calculator, guys, so just on your own with a quick sketch. The vertex, which is a point, it is the turning point of a parabola. Okay, the vertex, the x value of the vertex is negative b over 2a. So negative 8 over 2 times 1, that's coming from b and a here. Negative b over 2a, so the vertex, x value of the vertex is at negative 4. All right, that's your negative b over 2a. Now that I know that the x value of the vertex is at negative 4, let's find f of negative 4. So basically, plug in x equals negative 4 and find y. All right, so y is equal to negative 4 squared plus 8 times negative 4 plus 15. That's coming from, obviously, the equation we're working on. And when x is negative 4, what is y? Well, y must be, let's do this math here, 16 minus 32, which is negative 16, plus 15, that's negative 1, so y is negative 1. So we found negative 4 because the x value of the vertex of a quadratic equation can be found by doing negative b over 2a. Once you know that number, you can plug that negative 4 into the equation to find the output, the y value. So when x is negative 4, y is negative 1. So that's your vertex. Now your axis of symmetry, again, it's a vertical line that goes through the vertex. So let's make here just a quick sketch. So negative 4, negative 1. Our parabola opens upward. And it's a vertical line that goes through the vertex. And all vertical lines are x equals lines. So it's x equals what? Well, if you draw a vertical line through that point, x is equal to negative 4. So formula for the axis of symmetry is x equals negative b over 2a, negative b over 2a, because an axis of symmetry is a vertical line. That's an x equals line. That's a vertical line. And what is it going through? It's going through the negative b over 2a, which is the x coordinate of the vertex. So that's a quick sketch with nothing fancy. It is an upward facing parabola, because it's a is positive, with a vertex of negative 4, negative 1. And here's your axis of symmetry at x equals negative 4. Now guys, we're gonna spend a lot more time working on this, but I kind of wanted to give you a foundation here. Hopefully you took some notes, you've marked up some questions. We're gonna review this again and practice this some more tomorrow. Thank you for watching your introduction to quadratic equations.